how's it going? I hope you're well. In this video today I want to talk through the new features that have obviously gone to alpha for Kubernetes version 1.32, the latest version, also called Penelope. This was released in December of last year, 2024. So I'm only going to talk about the new features. Obviously they go straight to alpha. There were graduations to beta and stable as well. That's not going to be part of this video. This is just the new stuff. This is just a selection of the features. There are also more. If you go to the Kubernetes website, you can find the full list. This list here of 1, 2, 3, 4, 5, 6, 7 are the ones that Kubernetes themselves decided to highlight, so I'm going to do the same. What I've done is I've gone into the enhancement proposals to find out more info and summarize that and bring it to you, make it easy to digest. No matter what your level, beginner, intermediate or advanced, I believe that you're going to get value out of this video. So this is the list here. You can skip ahead. There should be chapters for this video. Let's go straight into the first one. The first one is asynchronous preemption in the Kubernetes scheduler, and this is brought from the feature group, special interest group scheduling. Now, preemption, if you don't know, is when you evict lower priority pods to help the higher priority pods get scheduled. And it's a heavy operation. There's a lot of API calls especially that are made, and it now runs in parallel because preemption has been decoupled from the scheduling cycle. And what this means, the benefit, is that there should be improved scheduling throughput when there are pods that require issuing preemptions. So that's what asynchronous preemption in the Kubernetes scheduler new feature is. Now, another feature is mutating admission policies using CEL expressions, which is new, and this comes from the SIG for API Machinery. So you can now use common expression language expressions to declare mutations. And why? Well, it's an alternative to the existing mutating and missing webhooks, which are overly complex. And in most cases, you can now use CEL expressions. And what it means is it's going to be faster, and also there's better integration with Kube API server. This unlocks some future possibilities. The third one is pod level resource specifications coming from SIG Node. And what this means is you can set now requests and limits at the pod level. So obviously this will apply in aggregate for all the containers in a pod. So this is simpler and easier to configure resource allocation at the pod level instead of previously at only the container level. And what this means is that if you have a multi-container pods, that there's better resource allocation. And they gave a great example here that, for example, you may have an AI ML batch processing workload, and you've got coupled containers in there, and they can now share overall the pod resources between each other as they need. Because you may have two containers, and sometimes the first container needs more of the resources than the second one, and at other times the second one may need more resources relative to the first one. But now you can set at the pod level, and they can just both use that. It's much better, much nicer resource allocation. And the next feature I want to talk about is that you can now have a zero value for the sleep action on a PreStop hook. So just a bit of background, you've got something called container hooks, which makes containers lifecycle aware, and they can trigger a code run. And there are two of these container hooks, and one of them is called a PreStop hook. And this is called just before termination. The other one is called when the container starts. Now what you can do is you can now set something called on the sleep duration, you can set it to be 0 seconds. And what this allows you to do is have immediate execution and termination. It sounds a bit crazy, but it wasn't previously supported. It now is. So you can now have immediate execution and termination. Now this is another new feature for dynamic resource allocation. There's now a standardized network interface data for resource claim status, and it's coming from SIG Network. Now this sounds like quite a mouthful. Let me break this down. Resource claim is a part of the Dynamic Resource Allocation API, otherwise known as this. Now what this does is, resource claim describes a request for access to resources in the cluster for use by workloads. Now this came about, I think, originally when you started to have things like workloads needing access to especially GPUs, obviously there's the whole AI thing going on, or things like network devices. And there's now a new field added to report what was previously invisible device status data. And what this does is it improves observability and troubleshooting, because previously this device status data was invisible, so we now have visibility into that. And there's also something as well as part of this feature is there's a kind of standardization of device status reporting that there previously was not. Another feature is that there are new endpoints for core components. So these are two new HTTP endpoints, and these will allow enhanced observability, troubleshooting, and debugging of the core Kubernetes components. So there's two of them, statusz and flagz. Statusz shows components' basic information, health status, and key metrics, and flagz shows the command line flags that the components were started with, which should help with diagnosing configuration issues and unexpected behavior. So debugging, troubleshooting, as mentioned earlier. This came from SIG Instrumentation. And the final feature, they called it Windows Strikes Back. I decided to just use exactly what they called it. This comes from the SIG Windows feature group, and this allows graceful shutdown of Windows nodes, which was not just wasn't possible previously. So the kubelet on Windows nodes is now aware when there's a node shutdown event. It will gracefully terminate the pods as you would expect and reschedule the workloads without disruption. And this introduces CPU, memory, and topology managers, and also allows for CPU and memory affinity for pods. Just a further note I wanted to mention, because this is always important with any new version, any deprecated or removed APIs. There are some APIs that have been removed, and this is for flow control resources. So you can see here that this relates to v1 beta 3 that no longer served. This is the information here, flow schema and priority level configuration, and instead you should migrate to use v1 API, which has been available actually since 1.29. So even if you're not going to 1.32 yet, if you are on 1.29 or above already, maybe you're upgrading to say 1.31 or something like that, obviously better you do it sooner rather than later. Don't wait for it to be removed in 1.32 and get a nasty surprise. You can start already. So I hope you enjoyed this video. If you did, please give this video a like. Please check out the rest of the channel. We got all kinds of cloud, DevOps, Terraform, Python, Linux, Bash, infrastructure as code, anything related to all of the above and more. Please consider subscribing, and I will see you again soon. Take care. Bye bye.